Welcome viewers, in this video we will see the solved problem based on the reciprocity theorem contain the DC circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the problem. Verify reciprocity theorem in the circuit shown below and also calculate the transfer resistance. So the circuit is given, right? So the reciprocity theorem is nothing but, we see that the voltage, the current source is available in the branch 1. We'll see that this is the branch 1. We are going to find the voltage in the second branch. Voltage current source available in branch 1, we are find the voltage in the second branch. According to reciprocity theorem, the current source in branch 1 is transferred to second branch. While transferring, the voltage in the second branch will reflected in the first branch. So that is the reciprocity theorem, right? Branch 1 contain current source, branch 2 we are finding voltage. After interchange, current source available in the second branch, so that voltage should be reflected in first branch. So that V divided by I is nothing but transfer resistance, that is 10 ampere. I is 10 ampere, we need to find the V value, voltage value. So V divided by I will give transfer resistance, right? So in the first step we will proceed the circuit as it is. We will find the V value. Then we will transfer the current source to second branch and find the V in the first branch. So that V divided by I will give the transfer impedance, right? So first we will proceed with the as it is, the diagram what is given as it is, we will proceed. Branch 1 contain current source, branch 2 will find the voltage across the 8 ohm resistor, right? So that is the step 1. So voltage across the 8 ohm, V equal to I into R, current flowing through the 8 ohm resistor into resistor value. What is the current flowing through the 8 ohm resistor? I8 we need to find. R value is, we know R value is 8 ohm, but we need to find the I value. What is the I value? I value is, so in this diagram, the 10 ampere is flowing through the 3 ohm resistor. At this point, the current is diverted. Using current division rule, we can find the value. Current is divided through this 2 ohm and 8 ohm resistor. So at this point, current is divided. So by using current division rule, we can find the current flowing through 8 ohm resistor. What is the formula? I8 equal to total current. This is the total current multiplied by the resistor of the other branch. What we need? We need a current flow through the 8 ohm resistor. So it should be multiplied by resistance of other branch 2 ohm divided by total resistance 2 ohm and 8 ohm. Current is divided in 2 ohm and 8 ohm. So the total resistor is 2 plus 8. Right? So current flowing through 8 ohm resistor is total current multiplied by the resistor of the other branch divided by total resistance, right? So 10 into 2 divided by 10 equal to 2 ampere. Now we calculated the current flowing through 8 ohm resistor. So that V equal to I8 into R, that is 2 ampere into 8. So 16 voltage. The voltage is 16 voltage, right? The current is 10 ampere in branch 1. The voltage drop in the second loop is 16 voltage. Now we'll go for interchange. We need to verify the same 16 voltage is reflected in the branch 1 while 10 ampere is transferred to branch 2. So one question we identified, V value is 16. Now we'll find the transfer impedance by interchange. So in the step 2, interchange the current source and response, the circuit given below. Here the response is V, right? So the current source available in this branch is transferred to the second branch. So that the voltage what we calculated 16 should be appear in the first branch, that is indicated by AB. We need to find this V value, right? What is V2? V2 equal to, that is the voltage across this 2 ohm. This voltage across 2 ohm is appear across this voltage across AB, right? Because of parallel. That is I2 into R. R value is 2 ohm. Because of open circuit, current will not flow through 3 ohm. Since the current through the 3 ohm is 0, right? So here also we can find the current divider rule. So at this point the current is divided through 8 ohm and 2 ohm. Here current will not be there because of open circuit, right? So the voltage across AB is nothing but voltage across 2 ohm resistor. Voltage across 2 ohm resistor is current flowing through the 2 ohm resistor into R. R value is 2 because current will not flow through 3 ohm resistor, right? Then how will you find this I2 value? Again we are using the current divider rule. I2 equal to total current multiplied by other branch resistor. So we need current through 8 ohm, so it should be multiplied 2 ohm. We need to multiply by 8 ohm divided by total resistance 2 plus 8 plus 2, right? So what we did is similar thing, 10 ohm total current multiplied by the resistor of the other branch divided by total resistance, that is equal to 10 into 8 divided by 10, 8 ampere. 8 ampere is flowing through the 2 ohm resistor. So that voltage across V2 equal to I2 into R. I2 value is 8, what we calculated, into 2, 16 voltage, right? So the V2 is 16 voltage. So same value what we got in the step 1, here also in step 2 we got the same value, V2 equal to 16 voltage. So while transferring the current source from branch 1 to branch 2, the voltage in the branch 1 now reflected in branch 2 will reflected in branch 1, that is the 16 voltage what we got at 16 voltage. So now we verified the reciprocity theorem and also we calculated the V2 value. Now we need to find the transfer impedance value. So in both the cases the ratio of voltage to current is same. Current is 10 ampere, voltage is 16 voltage. Hence the reciprocity theorem is verified. So the transfer resistance is V divided by R. V is 16 voltage what we calculated in step 1 and step 2. The current source is 10 ampere. So 16 by 10 equal to 1.6 ohm. So the transfer resistance will be 1.6 ohm. So in this problem we verified the reciprocity theorem and also we calculated the transfer impedance. That is, current source in the branch 1 is changed to branch 2. The voltage in the branch 2 will be reflected in branch 1. That voltage is nothing but 16 voltage. From this we calculated the transfer impedance. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.